So we have a system of equations. We have two equations with the same variables. You might also see it written with an open set. That means the same thing. So because both of mine happen to be linear equations, then we're essentially looking for the intersection of two lines. We're wanting to know where's the intersection, the point of intersection. So for this problem, since you have all of the variables grouped on the left-hand side of your equal sign, and you have your constants on the right-hand side, this system is set up nicely for elimination. We want to add the two equations together and eliminate a variable. So first, I need to go ahead and reorder my equations so that the variables are nicely stacked on top of one another and matching. In other words, I'm going to take my second equation and reorder it so that 5x is written first and 6y is written second, so that the terms that have the x's are on top of one another, and then the y's, and then my constants. Now, don't write this, but just think about what would happen if we went ahead and added the two equations together. 2x plus 5x, we're adding vertically, would give us 7x. Negative 3y plus 6y is 3y, and 7 plus 4 is 11. Notice, in adding the two equations together, we have not eliminated a variable. We're still stuck with both x and y. So we don't want to go ahead and add my equations together yet, because the whole idea is to eliminate a variable. So we must first do a little bit of work before we add the two equations together. We need to pick which variable we want to eliminate. And you can choose either one. On this problem, though, it would be easier to eliminate the y. And that's because if you look at the second equation, we have a term that has 6y. So if we wanted to eliminate that term, then we would need the top equation to contain a negative 6y, so that we would add these two together and they would basically subtract out and leave us with 0. So that means I'm going to need to multiply my top equation. Since my term is negative 3y and I want it to be negative 6y, I need to multiply the top equation by 2. But I must balance the equation, and what I do to the left, I must also do to the right. So we're going to multiply left and right by 2. So this gives me 4x minus 6y is equal to 14. So now I'm going to add my two equations together. And adding straight down will give me 9x. 6y minus 6y will subtract out. And that will be equal to 4 plus 14 is 18. Notice you have eliminated a variable, which lets you now solve for x. And you get that x is equal to 2. But remember, we're interested in the intersection of the two lines. So that means we want an ordered pair, an actual point of intersection. So now we need to take the x value and substitute it back into either of the top two equations. Let's say I choose the top equation, which was 2x minus 3y equals 7. So in place of x, we have found that our x value was 2. So I substitute in 2. This allows me to solve for y. So I continue solving. It looks like negative 3y will equal 3, and y will equal negative 1. So we have an answer of y equals negative 1, so my intersection is the point 2 comma negative 1. So we could say that this system is consistent. Consistent means that there is at least one solution. And we could also say that the system is independent. Independent because the two lines are independent of one another. They're two different lines. So you could classify the system as both consistent and independent.